I'm Gabriel de Maeztu. I'm the data scientist at IOMED. We are a very small startup here in Barcelona. We are fully dedicated to medical products. And today what I want to do is mainly make like an introduction into NLP. How many of you know what NLP is? Can you raise your hand? How many of you have done something with NLP? Okay, fair enough. Okay, so for those of you who don't know anything about at all, natural language processing or NLP is just a set of techniques, a set of ways of algorithms of working with text written by humans. So the idea is we have written text, and what we want to do is to be able to compute something that it's extracted from that text. So that's the idea of NLP. So what can we do with that? We can do a lot of things. We can extract information from the text. So maybe we are looking for something very specific. We are looking for a city, for example, or we are looking for someone, or we are looking for a date. Maybe what we want is to understand the document that we are working with. Maybe we want to classify a document. Maybe we have some PDFs and we want to understand the different kind of PDFs, but we don't want to start messing with the names, or maybe we don't know where they are coming from, and we just don't want we don't have the metadata to just classify them, so we can maybe use the content on them. We can use it for question answering. We can just use it for automatic summarization. There are a lot of many things that natural language processing covers, and today I'm not going to cover many of them. I'm just going to give you an overview of it, and I'm going to present you Spacey as a way to work in Python with NLP. So it's going to be a very practical approach, in the sense that I don't want you to understand like the very inner things about the NLP. I just want more to show you all the APIs that are available and how you can use them to build very useful stuff. And I will be very happy if people that hasn't worked with NLP just tries to do something after this talk. So it's just more a way of encouraging you to get value from the text. So as I said, text is everywhere, and it's everywhere because it's the way that humans communicate. I'm just talking to you, that can be written down, but the way that we usually message to other people, the way that we just left information usually to other people is not by writing tables or writing JSON files, but usually by writing the text. And this is especially true in two big fields, that it's medicine, that is the case that we are working, but also for lawyers. It's also something that happens in people that works with big documents. But yeah, mainly that's when you have that big problem that you want to work with text. So there are many resources for working with NLP. In fact, in Python itself, you have many libraries. But the one that I want to talk about today is Spacy, because it's very easy to use. It's an open source library, and it's a library that is made not so much to make research on NLP or to try new things on NLP itself, but making NLP a tool that it's easy to use and that you can get into your code really easily without having to look around too much with strange stuff. So it's something that it's built for production and not so much for research, but it's built on top of a lot of previous research. So if you start going through the code that it's written on Spacy, you will find a lot of very similar code that you can find in other research in a much more research-focused software. And it's a super nice starting point. So maybe if you are just working around with some text and you want to see if you are able to extract value without working too much on top of it, Spacy is a good way to start working with it. So to get started, it's just super easy. Just install the library, but one of the things that you have to do is to download all the files that come with the language that you are going to work with. Why? Because Spacy have already done a lot of work for you, building all the necessary stuff to work with multiple languages. So if you are working with English, Spanish, French, German, you have all those models already available, and if you want to expand them, there is ways to, but that's something that I'm not going to cover today because it's much more complex. So we got all the code, as I said, but we also get like all the necessary learning that most of the algorithms that are in this library will need. Why? Because most of the library, it's just different machine learning algorithms. So what you usually do is just download the code or the API, the way that you just use all those algorithms, but you also have to download all the models, and depending on what you want to do, there are different models that might fit you much more. So what you get is just an instance of the language that you want to work with and all the data needed to process it. So what can we do once we have downloaded all this information? Okay, what we can do is tokenization. We'll talk about that later, but it's just when we have text, when we have to go and find all the words. What we can do is understand each of those words, what kind of category do they have, what are the relationship between those categories, that's the dependency parsing, where does a sentence end. That seems pretty obvious. You say, okay, I will find and look for the dots, but they are not always there. Sometimes you have exclamation marks that might not help you. There are many very little tricky things in NLP that don't help you at all, and Spacey really what gave you is a way of doing those quite easily. One of the things that it does really well, and it works really well, it's named entity recognition. That's when you have a text and you want to extract something from it, and then as all the data, it's not work as a strings, but as a vector representation of the strings, you can do very fancy stuff that with it that I will not go much on detail today. So let's put an example to understand how Spacey can help us. We have a text, pretty long text. I don't know, you can imagine the Wikipedia, you can imagine a contract, a medical record, maybe something written by a lawyer, I don't know, emails, whatever. So imagine that you want to start working with it. One of the easiest things that you might think first is, okay, I'm going to chunk it, I'm going to just create the sentences. But as I said, you have all those punctuation problems. Don't worry, Spacey will get it to you. So what you only have to do is just you instantiate the NLP class. The NLP class is just a language class. In this case, it will be Spanish or English, okay? And you just throw to that language instance whatever document that you want to start analyzing, and it will return to you another object that it's the document. So the document is all the text that you have given to it, and what we are going to do from now on is just work with that entity that is the doc entity. So in this case, we want to just like go through all the sentences, no problem. We just go to the parse text, that it's our doc object, and ask for all the sends and go iterating over it. But imagine that we want to go deeper and that we want to go to the tokens, to the words themselves. Then in this case, we just threw the text into that language instantiation that we were talking about, and you just ask for all the tokens that are available in the documente. And it's just going to give them to you, so if you want to work with them, it's going to be quite easy. Let's imagine that you want to extract an entity. So Spacey has already built a pretty large model for you. So there are a lot of entities that it will recognize, and if it doesn't recognize it, but it's close enough and it thinks due to the vector representations, due to all the words that are around, it's a kind of word, it will just assign the kind of object that it expects it to be. So in this case, for example, Barcelona, it's something that we can expect it to be already in the model that we have downloaded from Spacey, but IOMED, our company, it's not there. I'm pretty sure that it's not there. So that company, it was able to understand that it was a company due that the other text that it was around it. So for example, in this case, probably a startup was a word that it really triggered that IOMED, that it was a noun in this case, it was possibly an organization. So it had a very good confidence, and it just gave the label to it for you. So pretty simple, pretty fast. You just go for it, load the language, throw the sentence that you want to start working with, and you start asking for the entities, and it's going to give you the entities already. The entities it's available inside the object, entities example. And because it's a pretty large class where you have like all the information from the very beginning until the end. More things that the Spacey does for you without having to do anything at all is to understand and to do like the part of speech tagging to understand each of those words, what kind of words they were and how they were related to each other. So you can pretty easily start like working with this kind of stuff. If you are interested on actions, maybe you should ask for all the verbs, and you can like pretty easily and pretty fast go give it all your text and ask and iterate through all the verbs and ask Spacey just to give you all the verbs, and then from there on just start moving and then start building the kind of stuff that you might be interested on. So how is this possible? This is possible because there is quite a large pipeline that it's built inside Spacey. So whenever you are instantiating the language, that it's what we are doing here, it's just taking all the metadata, all the files, and just loading them into a pretty large Python class. But inside of there are a lot of different functions that they just do very specific stuff. They just do it sequentially so that you get later on all the things that we have seen. So this is very nice, and it's a very nice of working with NLP. Why? Because you can modify it, and you can ask for the language all the available functions that are going to be processed during whenever you throw a text to it, but you can just create your own function that does something very specific. So here it does nothing, it returns just the same document, but imagine that you will be looking for the string Cristiano Ronaldo, and whenever you find the string Cristiano Ronaldo, you are going to assign some metadata to that document. So later on, if you are iterating over all your text, and if you want to look for the Cristiano Ronaldos, it's quite easy. So this is super nice, and it's a very nice way of working because it gives you this graph abstraction to work with all those pipelines, and you can do like pretty nice stuff with that. As I said, it does a lot of things for you, but you can modify them, you can just tweak them, and you can really get them to work into you. So one of the very usual things is the vocabulary. Vocabulary is all the words that are available in the pre-trained stuff that we have downloaded before, and it's a class itself. And it's really nice because it's shared by the multiple documents and also the multiple functions that you might work with. So whenever you modify the vocab, if you are like modifying it on the go, you can later on just whenever you ask for something, don't worry, it will be just the same kind of data. It's really nice to save memory because it's quite memory hungry. And it has some labels, it has some things, but you can just modify it and make it more suitable for yourself. So it's quite nice, but internally it doesn't really work with strings. Working with strings, it's quite painful. So what it does, and it's one of the things that I really like the most, it just takes all the strings that we see and it tries to find the lexeme. So if there is like I don't know if it will be, I don't know, coffees or whatever, it will just try to singularize it and to look for the lexeme. So it will be like to the minimal expression of that word. It will just create a hash of that string, and everything inside and everything, all the functions that are working inside the Spacey, they are just working with those hashes. So it's a very nice way of getting from the text into a way that it's much easier to work. Yeah, so as I said, this kind of data, it's data that you get, but it's data that you can modify. And this is like the really painful part of Spacey and any NLP processing libraries that you might work with. Why? Because you have to start creating your own data sets, you have to start tagging all the data, you have to understand if the tagging of the data that you are doing is right and it's for the purpose that you want. So there is a way of doing it, there is a way of enhancing it, but I'm not going to go in so much detail today because I think that that's not the idea of Spacey that I want to share today. The idea that I want you to get is that the Spacey can be a really just fire and go option if you don't want to do fancy stuff. So let's see some cool cases. Let's imagine that you are having some problems with GDPR and that it's giving you some pain, as I think that most of us have suffered. Maybe one of the things that they ask you to do, or that you want to do, is take all the documentation that you are maybe storing in your database or whatever, and you want to get and you want to erase or remove all the data that might be sensible whenever you are doing a backup, for example. So that way, if you are doing a backup of your database but you don't want to store names or phone numbers or whatever thing that you might find in your text, it's a pretty nice way to clean all that data. So you can remove all those things like addresses, documents, numbers, but that's something that you must do, but it's super easy to do. So I'm going to put an example that it's like close to what we do usually, that it's someone is going to the doctor and it says the name, but we don't want to store the name because we want to be as anonymized as possible. So one of the things that you can do is just throw your text into the NLP, you get your doc object, and once you have your doc object, it has found that Javier is a person because it has this previous information that you have generated before. So it's super nice because already this token has this metadata that it's pointing that it's a person. So what you can do is just go and iterate through all the tokens, and in this case just find those that are a person. In this case, it's per, but it's person. So whenever you find person, you just modify the string and you put confidential or whatever you want to put, or just erase it. But it's a very, very nice way and a very super useful way of using a Spacey right without doing any training and without doing any fancy stuff, but it might be very useful for you. Other examples that I wanted to share with you, there is a library that it's called TextAC. TextAC is like a even higher level than Spacey. But one of the nice things that TextAC does, it just gets around all the internals of Spacey, and it gets the typical NLP algorithms running on top of Spacey. And for example, if you are interested and you have like the Wikipedia page, I'm not showing it here, but you have the Wikipedia page of Barcelona, and you want to find for all the acronyms that might be there. One of the things that TextAC extract acronyms does for you is just looks for all the possible acronyms and just tries to go through all the text, finding the possible text that it might match to those acronyms. So that's something that it does for you, and it does it just like in a fly, and you don't have to do any strange kind of things. As I said, all the text that we are working in the inner part of a Spacey is not text, but vector representation of it. So there are some cool tricks that you can do. For example, if you pass a text that has manzanas, naranjas, and zapatos, that it's apple, oranges, and shoes, maybe you want to check from all the entities that might have found that are nouns, if those are similar between them. And as we have this vector representation of them, and there is a vector space where those words are located, you can see if they are really similar or not, and you can do much more fancy stuff like finding things that might for example, other strings that might have like the similar meaning, or that might be like in the same namespace, or that kind of stuff, without having to build your own vector representation. And I want to finish with a very nice example. In this case, I just downloaded like I found that a data set of news that were from the web that were about terrorism. So I just wanted to check really fast which were the locations where more terrorists might be found. So one of the things that I did, that it's not put it here, it's just ask for locations. So Spacey already gave me all the possible locations. I choose from them. So it went through all the text from the news. It found all the locations. I choose the one that I was interested on, and I choose also some groups, because it also finds groups and it has a metadata for groups. And from them, I just choose the ones that I knew that were terrorists. There might be more, I don't know. So what I did is just found all of them, and then go through all the text and try to understand how many times you will find one of those cities and one of those groups, and how away they were one from each other. And as I don't have too much time, I'm not going to go into detail, but in the end what it does, it goes through all the articles one by one. It tries to check if there is a city and if there is the terrorist group. I haven't done too much coding, as you can see. Just I'm asking for persons and I'm asking for groups, and to see if they match, and they are the ones that I wanted. So I can get a very nice dictionary where I can see like all the cities and the different terrorist groups, and I can really quite easily start seeing which of them operate more in some cities and some in another. So it's a super fast way of going through a lot of text and extracting a question, and it's super useful for building, for example, some data set that you might be interested on to enhance, for example, some other already structured information. So that's one example, and I want to end with the example that we do, just so you understand why we do this so much. In IOMED, what we do is we take medical notes, the ones that the doctor writes about you, and what we do is we go one by one looking for all the possible concepts that there might be inside. So we try to understand all the findings, all the anatomical parts, all the relationships between all those parts, and we are using some Spacey, but yeah, it can grow into something like that. Spacey wasn't there when we started, but it's one of the things that we are just checking now and that we are starting working with now. So you can see that it can get really complex, that you can start building your own models, you can start building your own vocabulary, you can change the algorithms, you can start doing a lot of very fancy stuff, but you can also use it for pretty simple stuff. So that's it. Thank you very much. And